EMO 2017, and it's the launch of this very exciting product. What is it?
So it's called XSYTIN 1. It's a new face stuff in ceramic, and it's, I've been keep saying this a couple of times. Most people know it's for the WG300. XSYTIN 1 has the ability to be as revolutionary as WG300. And I know that's a big statement, but it can do things that no other ceramics can. And that's kind of the part that is really, really interesting about it. So if you think about large components, for example in the oil and gas industry, where it's just not practical to spin them at very high speeds. So the challenge has always been, if you can't reach that 180, 200 meters, you can't use ceramics because it's not plasticized material. So you're down to carbide at the typical 60, 70 meters, and as if you're looking at the Inconels. With XSYTIN, you can get down to that 150 meters, which opens up all kinds of opportunities that are completely unaddressable in the past with ceramics. So that's one application. The other one is, if you look at aerospace, for example, you have the imbalance by design, where the component is just not practical to spin because of that. And again, you achieve the same thing. So that's kind of the traditional applications. The other side is, if you look at the non-traditional materials, we have applications today that we're milling in forging down to below 30 Rockwell steel, having tremendous success, saving customers literally millions of dollars. So it's a product that changes the landscape of ceramics as we know it.
What is the technology? What have you put into it that's making this so unique and so efficient and so productive?
It's magic. No. So it's a face stuff in ceramic, and what that means is that we basically take the raw materials of silicon nitride that we modify the grain structure, and we have an in situ grain growth. So if you take a look at, compare that to the traditional viscous ceramics, for example. Viscous ceramics is a matrix material where you have an aluminum oxide with crystals, the silicon carbide whiskers. In XSYTIN, we get the grain growth in situ in basically manufacturing process. And that makes a material that's twice as strong as the viscous ceramics. And the viscous ceramics are really amongst the strongest on the market, if not the strongest on the market traditionally. So this changes the landscape. If you take one step back on what that really means from the customer, because at the end of the day, I can talk about how strong it is and so on. It gives us a couple of things. First of all, in terms of feed rate, instead of the typical, again, an Inca 718 with a half inch round, the RNGN 45s, you typically start about 0.2 feed rate. So with XSYTIN, we start between 0.3, 0.35, 0.4, so much higher feed rates. That's one side of it. The other side of it is just incredible predictability, because you're not risking having that catastrophic failure. So you can continue.
So you've got process reliability, because in ceramics, quite often that's a bit of a worry for an engineer to go from carbide to ceramics, but you're saying you've got increased reliability.
Absolutely. I mean, if you think about XSYTIN, you think about the traditional materials being used, it kind of gives you the feed rate capabilities and reliability you would expect with carbide, but it gives you the speed capability that you would expect with ceramics. So it kind of marries two worlds that is really, really interesting, and it really allows to be able to use the tool in a different way than traditionally would have.
So you could say it's a game changer.
Oh, most definitely it is. It changed the world of ceramics.